Alright, this video I'm going to talk about another function which we can find critical points for this function. Okay, as you know that critical point consists of stationary point and singular point. If there are no endpoint, so if there are no endpoint, there are only two types of critical point: the stationary point and the singular point. So to find critical point, at first we must differentiate the function, right? We have to look at the first derivative, because first derivative is related to the gradient. Okay, the gradient. So critical points, the gradient is either the dy dx is either equals to 0 or the gradient is undefined. The gradient is undefined. So as long as it's fall to these two categories, then this is a critical point. So then we differentiate this. We have 2 over 3 x plus 2 and 2 over 3 minus 1, right? And you differentiate the function inside there, you have 1. So you have 2 over 3 x plus 2 to the power of negative 1 over 3, right? 2 over 3 minus 1, you have minus 3 over 3, you have negative 1 over 3. So you have 2 over 3 x plus 2 to the power of 1 over 3, and this is your f prime x. So I jot down here. So because this function is very important, the gradient function, so which is 2 over 3 x plus 2 to the power of 1 over 3. Okay, this is as my reference to finding the critical points. Okay, let's see. Alright, okay, let's look at the critical point here. So the critical point here, as you know, that it must be dy dx equals to 0. So one thing to tell you is that you have to identify the domain. The domain very important. Means that the value of x that you find as a critical point must be in the domain of fx. Okay, the domain here, as you see, that x plus 2 to the power of 2 over 3, x can be accept any value. Right? For these cases, the x can be accept any value. Okay, any value of x, you put 0, you put negative 2, you're getting 0. You put any number, you're getting a number also, right? So means it's a negative infinity to infinity. You can accept any value for the real number. So f prime x equals to 0. So the first case here, dy dx is 0, the critical point. So is it possible for f prime x to be 0? That's the case that we need to consider. For example, this case, 2 over 3x plus 2 power 1 over 3 equals to 0. It's like impossible, right, for this function to be 0. As you see that the numerator is a number, right? A number divided by something, a number, it won't turn out to be 0. Even though this 2 divided by 0 is undefined, it won't become 0, right? So there are no value of x such that this f prime x to 0, right? So means that no solution for this, right? There are no solution for this. So means that there are no value of x that to be 0. Means that for this case here, we have no stationary point. Okay, no stationary points. Why? Because dy dx cannot be 0. How we see? Okay, this is the function down here. There are no x up there, right? So means that a number divided by b equals to 0 only if a is 0, right? Even though b0 is undefined, so only a0, 0 divided by a number, only you're getting 0. But this is a number, it's not a 0. So man, this thing will not be 0. Okay, it will not be 0. So there are no solution for this case, no stationary point here. Okay, that's a very important understanding. So now, but is there any more critical points? Right? Yeah, there are no critical point belong to stationary point. Okay, these types. So, but there is a possibility of dy dx is undefined. Okay, look at this function here. Look at this function here. So, f prime x equals to 2 over 3 x plus 2 to the power 1 over 3. X equals to negative 2, we're causing this to be undefined. Right? X equals to negative 2, we're causing this to be undefined. Why? Now you know, because undefined, 3x plus 2 should not be, should be 0. F prime x is undefined. When this thing equals the denominator equals, you cannot divide a number by 0. So then you turn out to be, if you're solving this, 0 over 3, then you're getting x equals to negative 2. X equals to negative 2 is in the domain because negative 2 can be accepted here. What is the meaning? Means that if you're putting the negative 2 inside here, you are getting the value of y. Then that is a critical point. So it means the value of y for this point is when x is negative 2. When x is negative 2, your y is negative 2 plus 2 to the power 2 over 3, which we're giving you 0. Means that negative 2, 0 is a critical point. So in this case, there are only one critical point. Okay, because there are no stationary point and only one critical point. And this type of critical point is not stationary point, it's a singular point because the dy dx is undefined, right? It's a singular point. So, alright. So, okay, I'm going to use the calculator and show you, using the apps showing you how to, as going to Desmos, okay, Desmos. So try to do some research on the graph, what happened to the graph. So you just key in this function, you just key in exactly this function here, x plus 2 to the power of 2 over 3, right? So you can put in bracket from here, x plus 2, right? X plus 2, bracket again, then you have x plus 2, then you key in the a power b. So you key in 2 over 3. 2 divided by 3, okay? 2 divide by 3. So you can see, if you look at this graph, okay, I try to zoom far. You can see that there are no stationary point here, okay? There are no stationary point here. Stationary point, what is stationary point? If you look at the graph that I'm using Desmos, the graph will be looking this way. It's just like a bird. Right? So there are no stationary point, means that the gradient all is not parallel to the stationary point, means the gradient is parallel to the x-axis. But there is one point, the critical point, where's the dy dx undefined. So if you see carefully here, if I zoom, if you look at here, it's like 0, right? No, you should not. You should zoom. If you zoom, you carefully, you can see that it's the sharp point is at negative 2. Can you see that? Negative 2, 0. Negative 2, 0, which is a singular point. Okay, this is also a critical point, whereas the dy dx is undefined. Or we said it's not differentiable at negative 2. Fx is not differentiable at negative 2. So then you can see that there is only one critical point for this function. Alright, so now you have understand how to find critical point. Okay, so I will give you another examples.